All right, good morning, everybody. We'll get started. Okay, a couple announcements. Let's see, I'll probably post the practice exam today, this afternoon. I'll try to get to that. What that will be is it's actual problems from prior offerings of this course. Some of them written by not myself, so they might be slightly different from what I would ask, but the theme and the content's about the same. I think there's probably like say 2 exams worth of problems that'll be posted, and then I'll have the solutions for most of the problems that go with that. If I have them available, I'll post them. One thing that you want to maybe think about for the exam, and it's something that we haven't done so far in this class a lot of, but you might go through a problem and you might get to the point where in a homework example you'd be asked to plot something. Here you're not able to do that because you don't have software. But what you could do is you could sit there and think about the boundary conditions and think about the temperature profiles and sketch something out. So you should maybe practice that a little bit. I'm not saying that that's going to be on the test, but it is a fair game thing. Like I could say, think about some example where you have, let me just sketch something out. So like let's say, I give you an example where maybe you could take these examples here, right? These boundary conditions here, but let's just say it's in 1D, and I say, okay, this is a plane wall, or not a plane wall. What would this be? Maybe you have a problem with generation or something like that. So you have a problem with generation, and these are the boundary conditions. And what you would do is you'd sit there and say, okay, well, I know my temperature and my plot is going to have to go from 0 to some t, infinity or something like that. And I'd look at it, and my temperature plot would have to start at 0, and then I'd have to make sure my dt dx at x equals w is 0, and you'd plot something out that sort of fits what your boundary conditions are. So what you'd be looking for when you're asked to do this is make sure the boundary conditions match. Like, so your drawing matches the boundary conditions. And then you'd want to capture any important shape that there is to the curve. Like if it's a generation problem, it might look like this. If it's something else, maybe it's linear or there's a concave feature to it. Whatever the problem dictates, you want to just make sure you're capturing those types of features. And that's really like, if I was going through and grading a problem like that, I'd be looking for whether you're matching the conditions and matching the form of the equation, not necessarily whether you're getting everything exactly, point by point accurate. Okay. If you had me for 364, I guess that'd be a while ago now, but we did stuff like that in that course too. So just be aware that that's a possibility. I guess there was a slight oversight on my part that I didn't assign a homework on that, but I think with the practice exam, I'll try to pick out some problems that can do that. Any questions on that? Okay, so I guess the exam itself is scheduled for a week from Monday, I believe. I think that's where we are with it. Okay, homework 4 is posted now. It should be up on Canvas and available to download. That's going to be due next Friday. It's hopefully a little bit shorter than the previous homework, so you can have time to study for the exam too. It's just one problem, a few parts, but it is a 2D problem that you're going to be solving. So yeah, have a look at that and see if there's any questions. The other thing is lecture a week from, 2 weeks from today, is going to be recorded, so we won't meet in person on March 3rd. It'll just be uploaded and recorded. I'm traveling along with a couple other people, so that will be uploaded probably the Thursday, Wednesday, something like that before lecture.